So we've now seen how transparency and supply chain mapping can provide insight on supplier packaging with beer, and we've seen how it can provide insight on kind of missed opportunities with the hospital, and we've seen how it can provide insight into supplier decision-making for dog and cat food. So now let's go to our final case study. This is, I think, the most interesting and my personal favorite of all of the case studies, shoes. And in this case, we start to look at kind of the design of the shoe itself and how product strategies can emerge from supply chain carbon mapping. Here's our famous bubble diagram that demonstrates the various hotspots for shoe manufacturing. And what really emerges here is that it's the materials that are going into the shoe itself that contribute most highly to the carbon footprint. So we have leather, we have various kinds of plastics, and we have fabric as the biggest hitters. Now let's imagine a fictional company that's making multiple different kinds of shoes. There's shoe A, there's shoe B, there's shoe G, and each of these shoes has a different amount of revenue that's bringing into the company, and each shoe has a different greenhouse gas emissions per shoe. So now we've plotted them on a graph where we can see that, for example, shoe G has the highest revenue and it has a pretty good greenhouse gas emissions per shoe, but shoe B also has a great revenue but has a really high greenhouse gas emissions per shoe. So then we can ask the question, can we focus in on shoe B, and can we think about ways to remanufacture the shoe or redesign the shoe using different types of materials to reduce the greenhouse gas emissions of shoe B? And this is kind of the standard opportunity that you might imagine when you're doing a product carbon footprint analysis. But there's also this interesting opportunity with shoe D, which is that it has a very low revenue but also a very low greenhouse gas emissions per shoe. And so by simply marketing shoe D and trying to increase its revenue, the overall footprint of the company per dollar sales would go down. And so now we're involving all the different business units in the company together. It's not just manufacturing, it's not just product design. We really have marketing involved, and we have everybody in the company involved in reducing the total company's greenhouse gas emissions, which is exciting. So in conclusion, Chris talked about how supply chain mapping can meet different stakeholder needs and is actually being driven by different stakeholders, including the World Resources Institute's emerging standards and Walmart's interest in supply chain environmental impacts. We talked about how supply chain mapping can identify unexpected opportunities. So we saw how supplier strategy emerged from looking at grain production for dog and cat food manufacturing. We looked at how, when we looked at beer production, because the cans and the glass bottles were the biggest part of the footprint, packaging redesign was a new and unexpected opportunity. And finally, when we looked at shoes, we saw that product strategy in terms of either manufacturing or redesign or simply marketing, understanding which of the different shoes are low carbon alternatives and marketing them as such could reduce the total carbon footprint of a company. And as I mentioned, altogether, this really maps across various business functions of a company and is able to get everybody excited and everybody involved, which is what we need to actually see real change globally and see real reductions. And finally, one of the most important aspects of doing a comprehensive supply chain carbon mapping is that you're avoiding wasted efforts. So you're not going to spend a lot of time analyzing an aspect of your supply chain that turns out to be unimportant. You're not going to spend a lot of time figuring out ways to change light bulbs in a specific facility when that turns out to be 0.5% of your total carbon footprint. You're going to find out that grain is 30% of dog and cat food manufacturing, and you're going to focus on grain. This also means that at the end of the analysis, if somebody comes to you and says, well, I saw that you did this analysis, but you didn't include the label on the dog and cat food package, what about that? You're not going to have these kind of what-if questions. Because you've if you are comprehensive from the beginning and you estimate emissions across your supply chain from the beginning, there are no what-if questions. You can say, oh, we already did an estimate of that, and we saw that it's less than 1% of our footprint, so it's not something that we will worry about. You won't then have to go spend another year digging into something that might turn out to be unimportant. So with that, thank you very much. I think we have a couple questions here.
Actually, Corinne, we've got lots of questions, and not surprisingly, most of them are for you. The first one I see coming up here is when you talk about consumer products, such as shoes, beer, etc., are you including distribution, that is truck fleets with fuel and emissions, etc., and also including energy use for both the product manufacturing facilities and the retail outlets too?
That's a great question. So the way the model works is everything that happens upstream from the product leaving a manufacturing facility is included. So, we're looking at shoe manufacturing, for example. All of the direct energy use that's happening within the shoe manufacturing facility is included. All upstream transportation is included. All upstream energy use is included from all of the facilities that are upstream of the shoe manufacturing facility. We don't include retail of the shoe. However, if we looked in our database from a different angle, we could look in our database at a retail position, and we could see the impact of retail's energy use and electricity use, as well as all upstream transportation and manufacturing. But here we've just focused on manufacturing and its upstream emissions.
This question is related, but a little bit more generic. And the question is, what cost elements and formulas did you use to calculate greenhouse gas emissions?
This is a very fun question for me, because this is my favorite part of what we do at Climate Earth. We use a formula that was developed by Wassily Leontief in the 1960s. And he actually won the Nobel Prize in Economics for this discovery. He discovered that by taking information on money flows in an economy and taking this matrix and inverting it, he could then trace how money flows throughout an infinite economy. So he's capturing all of the spend that occurs throughout an entire economy. And we are doing a similar thing at Climate Earth for greenhouse gases. So we'll capture the full impact of greenhouse gases across the supply chain, across the infinite supply chain, using his fundamental formulas and discovery. And I would love to provide anyone with papers on what Leontief discovered if you're interested, so please feel free to email with questions.
Here's a more generic question. How do you track improvement in GHG reduction over time? If a product is re-engineered, for example, how do you take this improvement / re-engineering into consideration?
Well, I'll answer, and then I'll let you finish the answer. How about that?
Okay.
So our model works with the company's financial information. So if 1 year a product is being produced in a certain way, we will capture that, and we'll capture the quantity of materials, and we'll capture the quantity of energy used to do the manufacturing. If then the product is redesigned and the next quarter or the next year the inputs to the company change, or the inputs to the manufacturing facilities change, we capture that automatically in our model.
Well, I just got a comment, which I'll just pass on to you. Cool. Good insights and examples. Thank you.